Quantum computing is a complex area. Clearly, there are a ton of PhDs in quantum mechanics and other disciplines working in this area, whether it's chemists, materials scientists, mathematicians. And for our kind of quantum computing, we've had to invest in both the mathematics, the physics, and the engineering to make it happen. But as we start seeing the emergence of tools and sort of software such as the full stack we're developing, the quantum computing will start becoming more accessible to more developers. Now, this is never going to be the same thing as writing a Hello World program necessarily in C# or in Java. You're certainly going to need to have an understanding of the way the quantum algorithms work, but it will not be something where you need a PhD in quantum mechanics in order to write your first program. It doesn't matter what technology you're talking about, whether you're storing data on a disk or whether it's communicating over Ethernet. All of our technology has embedded within it some kind of error correction to solve for random problems that occur in storage or in communication. With quantum computing, this gets even more difficult, simply because the quantum states that we hold, these qubits, are very, very sensitive to external interference, whether that be cosmic rays or just random particles going through the environment. And so being robust and being tolerant of errors is a really important part of building scalable quantum computing. So what we're doing, our approach, is using something called topological qubits. And these are based on a kind of particle, it's called a quasi-particle, which essentially is much more inherently stable and resistant to external interference. So at the moment, we're very much engaged in heavy research. We've done the maths, we've proven out the physics, now look at the engineering of actually getting a scalable full stack solution working. The end game is clearly we aspire for our customers to be able to access quantum computing on our Azure cloud. Right now, we have various forms of virtual machines, and we can do high performance computing and other things, and we clearly aspire to complement that with quantum computing capabilities when we can bring that full, scalable, reliable, enterprise grade quantum computing to our customers. And that's really the end goal we're working towards.